again, the only way that the table works is the area to the left. So like some people are getting confused. Just because you shade it, that doesn't mean that when you look in the table, it's going to give you the shaded area. It's always going to give you the area to the left, so you figure out, what you need from that. But look up a cumulative area of 0.8925 and find the z-score that has that amount to the left of it. Very good. Everybody okay with finding that score? Looking in your table, right? Any issues at all? Okay, so just kind of using the table in reverse. Now, are they always going to be accurate or exact? No, you're going to have to just approximate the closest z-score that would give you that area, okay? All right, another little topic here is find the z-score that corresponds to that. So like when you get, there's a lot of P's in statistics. What does that one mean? Right. So we're trying to find the z-score that corresponds to the 5th percentile. And again, the 5th percentile would be 5% that would be below that particular value. So find the z-score and look this one up because there's something in there I want you to note. So what do you see there, Cutter? What are the values the closest values you can find?
0.0495.
Or?
0.0595.
Right. So if you have a z-score of negative 1.64, that's your probability. And if you had a z-score of negative 1.65, that's your area. Well, guess what? Right in the middle. 5% is 5 thousandths or 5/10,000ths away. So then what we're going to do with this is we're going to average these two together. So negative 1.645. So that would be about the only one where you're going to have a z-score that's going to be 3 decimal places. Because it's right smack between those two percentages. So then we average the two z-scores. Otherwise, pick the closest one. Okay. This will be one that you will see lots of in the future. You'll see that z-score all the time. There's a spot, and I'll show you that when we get to that. Okay, so again, we're trying to find a score. That was the idea behind this lesson here today. Well, you might be asked to find a raw score. Okay, so tell me this question. Tell me this. What was your formula for z yesterday? Z equals signal. Okay. Okay, so here's the deal. This formula and this formula are the same. Just solve for different variables. Okay? So if you're asked to find the z-score, if you're asked to find a raw score, that might be a weight, a height, a distance, an IQ, but it's just a value that has context with the problem. It's not the z-score, but it's maybe a raw score. Okay, so let's see if we can find a raw score. In fact, maybe a couple of them here using that formula from the next example. So it says I said a vet last time, so I had a veteran. So a veterinarian is what I covered that with. But a veterinarian records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. Find the weights, X, that correspond to z-scores of the following. Answer me this question. What would this cat, what kind of cat is this? What would you say? It's a heavier one because it's going to be almost 2 standard deviations above the mean. What kind of cat is that?
An average.
Average cat. below average cat, a lighter cat, right? So here's the first one. Okay, so the raw score, the weight of this cat would be the average weight, which is 9. And again, I'm just going up here. Average weight plus the number of standard deviations times the standard deviation, and that's going to give you a value, and that's going to be the value of that animal. So it's going to be about a 12.92 pound cat. Not huge, but bigger than average. And then the next one, 9 plus negative 0.44 times 2, that's going to be a little bit below 9, that's going to be about 8.12. And the last one, you need to calculate? No, it's 9. So that's just using that formula that you got. Okay, let's look at one more thing here. Okay, so now we're talking about scores for a California Police Officer Standards and Training Test that is normally distributed with a mean of 50 and a standard deviation of 10. It says an agency will only hire applicants with scores in the top 10%. So what's the lowest score you can earn and still be eligible to be hired by the agency? So do you think that the cutoff score is going to be above 50 or below 50? It's going to be above 50, right? So the question is how much? Well, what I'm going to do is I'm going to try to draw a picture of what's going on here. So where's the cutoff score going to be at? You said above average, so maybe just put it here. What else could I label in this diagram? 10% where? Above, right? So this score here on this axis is going to be a score that cuts off an area above the curve that's 10%. So this would be 90. It would be the 90th percentile. Now here's a huge mistake that people make, and I don't want you to do this. Your formula is mu plus z times sigma. You don't have the z is right. You do have the mean, and you do have the standard deviation. The standard deviation is 10, but you do not have the z-score. A lot of times people put in the percentage. If you put 10% in, it's wrong. If you put 90% in, it's wrong. You need to find the z-score, right? Z-score of average is 0. Z-score of above average at the 90th percentile is what? Look it up. Look up 0.9000, and that would be your z-score that you're going to use. Yeah, it's in between, and it would be closest to, right. So look in your table for it. You're looking up an area of 0.9000. And the closest you should be able to come to is like, it's 0.8997, I think. Well, we're looking at 90% though.
Which one would be closer to 90?
Right.
And 97 is closer to
So you're looking for an area of 0.9000. So 0.9000. 8997. So that would be 1.2. So doesn't that make sense that if you're scoring at the 90th percentile, you're going to be 1 and a fraction standard deviations above the mean? So take it times that, and that tells you the amount above the mean you are. So 62.8 would be your cutoff score. Now, if I made you round this. Should you round it to 62 or 63?
63.
Right, because 63 means that you're going to be in that top 10%. 62 means you'll just be outside of that probably. Okay. So real big issue here. Don't put anything in here that is a percentage. This is not a percentage. This is a z-score for a percentage. Okay. Big issues. People make that mistake all the time.
So
Okay, go ahead.
what percent? So what
The
is it?
percentile,
I got it right.
it would be at the 90th percentile.
I know, but what does that mean? Okay, I got that right.
Okay, because that would be like, let me show you.
Mm.
That would be this value right here. So if somebody scored a 50, they're at average, they have to score at, so like the z-score would be that,
Okay, yeah, I got it.
and this would be the raw score for that z-score. Okay. Okay, so one other thing that's not on your notes that I'm going to do one and then you do the other is finding the z-scores that doesn't cut off the left or the right, but the middle percentage. So if I drew a picture of this, clearly I'm going to put the middle 80% here. And what would be the z-score that cuts off the middle 80%? Well, you got to work with percentages. What here? 10, right? So if you got a total of 80 in the middle, then you got 20
Right.
divided evenly on the left and the right. So this value here and this value here are going to be identical except negative and positive. So if you got the negative one, you got the positive one. 10%. Look it up. 1000. Closest z-score that has 10% to the left of it. Very good.
Oh, we just looked that up.
Right, and so the other one that we looked up is we looked up 90%, which is that positive one. So we wouldn't have needed to, but if you wanted to actually look it up, you would look up the 10th percentile and the 90th. So draw a picture for the next one and calculate the z-scores that cut out the middle 10%. Draw a picture. See if you can figure out percentages within that distribution and then find the z-score for a percentage that you're working to find. You need to consolidate your water bottles a little bit there, Lexi. You got like a half, a third.
These ones are empty now,
Oh, okay.
but they weren't a little bit ago.
Oh.
I like to open them and just not finish them.
Right.
And keep them on me for no
Right,
reason.
right.
You should see my bed.
Yeah.
I don't know.
It's okay, I do it too. Do you like balloons? You forget where you put it.
Well, like I'll have one half gone in my bed, but then I know that I'm gonna want more than half, so I just grab another one and I don't drink half. But then I only drink half of it. I don't understand.
I get it. She has a little bit in a bottle,
But you don't want to drink.
but she knows that she wants more than that.
Yeah.
So she knows she has to go get a new one. So she just drinks out of the new one, but doesn't empty the old one.
You can maybe get an actual big water bottle.
I had one,
And
but
then pour the rest of one in there, and then pour the
I
rest in
had one, but I threw my backpack in my car and it broke the straw off it.
I'm gonna try another one.
Okay, so what goes here and here?
Or bigger.
Right, so 10 from 100 is 90. 90 divided by 2 is 45. And so if you look up the z-score for the 45th percentile, it is negative point, right. And then this one here would be a positive 0.13. So 0.4500, look that up. Make sure that you see that 0.4500.
Does it matter if,
They're even.
because I did the average in between them, does it matter if
Unless they're right in the middle, just pick the closest one.
Oh,
The closest z-score. Anybody got any issues?
I don't get it at all.
Oh, that's so bizarre.
Like, I get that I have to, like, do this, but then I don't
Okay, so
understand.
what is that? That's a percentage, right? Okay, well, see, this is a percentage, this is a percentage. These guys are the percentages, and these would be like the z-scores that would cut off these percents. So if, I'm not gonna look up a z-score of 0.45, this is not a z-score, it's not a value on the z-axis. It's a percentage in here, so we wanna find a z-score that has that percentage below it. So we're gonna look for 0.4500, so 4500 is about there or there. So that's why it's negative 0.1. So that's the closest we can get to 25. So that's why we would put negative 0.13. And by symmetry, it's gotta be the positive on the other side. So we don't need to look up there.
okay. This, I answered it yesterday, and it's this student from NDSU, and she keeps calling me, but she